So today we're going to start up on 37. Since yesterday was the first official day we did Pythagorean theorem, but again, we've seen that before. A couple of different ways of looking at it though. So just wanted to put this out here a bit. So let's say, for instance, we're looking at number 1. It says to the following lengths form a right triangle. Now this is a little sneaky because there's no right angles put into the triangles. Now we can kind of tell where they're at if we really wanted to go that route. You can kind of see this looks more like a right angle. I could put it in myself. But if I assumed, if I didn't have it there, I could still tell which places to put my A, B, and C because the C squared is always going to be my longest side, my hypotenuse. So all I'd have to do is look at the 3 numbers and say, hey, where's the biggest number? That's going to be my hypotenuse. That's my C. The other 2 shorter legs that we have are interchangeable. You could make either one of those A or B. So all we're going to do is go ahead and get this plugged in and see if this is going to be correct or not. So 6 squared plus 8 squared is 100. 9 squared is 81. Yeah, that does not equal. That would tell me it's not a right triangle. So Hardy trying to sit here and create it and make it one, not a good assumption in that case. That's why we don't have the right angle there, because we don't know for sure. So I guess we'll put that on at the end if we feel like it. Let's play with one more, just to kind of see here. There's my biggest number, so that's my C. So it's 5 squared plus 12 squared equal 13 squared. All right, let's see here. 5 squared plus 12 squared is 169. 13 squared is 169. This time we can put the right angle in because it's actually a right triangle. So we're just plugging in and testing out with those. And whether you have a picture or whether you just have A, B, and C, well, that's kind of nice. I don't even have to think about it. Being nice and telling me. So I can see how that works. The other ones on the bottom are a little more traditional. So like, so we're going down a little bit here. So like if we're doing number 7, there's my right angle. My C, my hypotenuse, is always the side opposite that. So this is my C. The other way you can know if you're not sure, just kind of as a quick reminder from yesterday, your 2 legs are going to create the right angle. So since these 2 sides, when I put them together, create the right angle, that also would tell me that they're not the hypotenuse. Okay? So we got A squared plus B squared equals C squared. So
this is gonna come out to a decimal.
It's true, and we kind of got a little bit of a warning here when it said, hey, find the missing lengths to the nearest tenth. You're like, wait a minute. So square root of 80, yeah, we're going decimally here. So C is, what have we got, 8.9. So yeah, don't be like, I did something wrong, I got a decimal. Nope, that's gonna happen on some of these. You may get some that don't get decimally, but some you may. Okay, so just kind of keep an eye on some of those things. And we're going, but make sure, labeling sides as we go to make sure we got the right side. Let me see what else I got rolling on this. All right, let me keep turning here. You're like, Hardy, we got a lot of these. And we've talked about this before. Even if you did evens or odds on these, that'd be fine. I do want to do one more, though. I want to do 15. Because again, I got 2 sides, but notice this time, okay, bless you, here's my right angle. So my A and my B form the right angle. Well, I don't know this time. And my longest side, my side across from my right angle, is over here. So we chatted yesterday about a couple of ways you could tackle this.
You could like minus 3.6 squared.
That's right. You can do it two ways. I'm going to write down both. You can kind of pick which way you like best. If you're a traditionalist, you keep A, B, and C in the same spots and you kind of work it out. Or, let me go post-it note here. Thank you. So I could do it this way, but I like Emily's way too. So let's kind of see what we get here. And we'll see which way we like best. Oh my gosh, except Hardy cannot write what he sees today. That says 54, not 57. We'll get there. So we got to bring that 12.96 over because we want to get b squared by itself before we do the square root here. Now we're ready to go. So we got about, if we go to the nearest 10th, 6.5, let's say. But Emily had come up with an idea that was going to make this go shorter. We like shorter. You can always take your hypotenuse squared and just subtract the leg squared that you have. And then we're going to get it done really fast. Because now we're just going to take the square root of that number and I end up in the same place. So either way that you are comfortable with is fine. Because they got us the same answer. But again, this only works if the hypotenuse is one of the two values that you have. Otherwise, we should just stay as a traditionalist. So those are basically your only two options. You're either going to have both legs, and we're finding the hypotenuse, or you're going to have one leg in the hypotenuse, and you're trying to find that other leg. Pythagorean theorem in a nutshell. Okay. Next piece of the puzzle, because now we got to go backwards a little bit, start seeing what's going. So we got a little bit of a study guide here. We, if you didn't notice already, I'm going to flip forward to page 40 here. There are several questions that have been X'd out because it's not some things that we hit. And I'm noticing a couple of others as I get here that we need to X out. I'm Xing out 3. We didn't do literal equations yet. Yeah, we rearranged a couple of things that we needed to do from before, but that's okay. So I'm kind of looking at this. I'm like, okay, a lot of equation stuff, a little bit with graphing, so we need to kind of keep an eye out here. So I'm going to bounce around a little bit, okay, just so we can make sure that we touch on everything. So let's see. Might as well start at number 1, just to play it safe. That 3 is only going to these things in parentheses. Don't distribute it all the way out to the 5x. That's going a little too far. Now comes the detail stuff that can throw people off. My x terms are on the same side of the equals. Don't do opposites. They're together already. So just go ahead, add those up. And then it's going to look more like a traditional two-step equation that we're used to. Get that x term alone. Divide by 8. Work that out. So a lot of things with just plain equations in there, no big thing. Inequalities, we are going to have some graphs in a couple different ways. One of them's on a number line like we have here. Same thing as though I was solving for something else. Now, some of you may prefer or would try to get the fraction out of there first. I'm not a huge fan of that personally because what tends to happen is people will multiply the 2 here and here and they forget about the 4. That's why we want the external loan first. Then we can go ahead. No flippage here. We didn't do a negative to both sides, so we're going to just leave that be. And you've got some flexibility with your number line. I'd always ask that you get at least 3 numbers on there and not just the 1 number of your answer, just so we make sure we can see your number sense is good. Other than that, I see the arrows going right because x is greater than. What symbol am I going to use at my 10, though?
A solid.
Sounds good to me. Okay. So yeah, we got to show that difference too to show if it's equal to or if it's not. So let's see. What else have we got working here? I'm looking for weird. Weird is always... Let's play with 5. Word problems show up a lot. So let's see what we got here. Adriana gives half of her t-shirts to charity. Then she bought 3 new ones. If she now has 14, how many did she have originally? Okay. How many did she have originally? That's our x. Now she has 14. So whatever this equation we're going to solve is going to be, it's going to equal 14. So if she buys shirts, so however many shirts she had, she bought 3, but she'd taken that, she gave half of them to charity. Here's the part of this that can be a bit tricky, because it might be tempting to write it like this, but if I did it like this, this would be saying I donated half to charity after I bought my 3 new shirts. I'd include those. We don't want to do that here. I had my shirts. I gave half of them to charity, so I cut them in half. I divided by 2. But then I bought 3 new ones. And so now I have 14. That's the part we got it. So now it's a whole lot like number 2, except it's not an inequality. And I really should have written this equation up a little further, but we'll make it work. And the opposite of divide is to multiply. And get to our solution. So just kind of taking the pieces, because you notice on that one, I didn't start with the left side. I started with, hey, this is what the answer is going to be. Let's keep working in pieces until we get there and then kind of see if our answer is sensible or not. And that's reasonable, because half of 22 is 11, plus 3 is 14. Okay. That kind of works out well for me. So just again, in a short period, we've done a lot of stuff. All right, so we'd cross that out. We'd cross that out. Yeah, all these, any of these literal equations that you see that have all these other funky multiple variable things, if Hardy forgot to X them, and we see that I did, yeah, that can get to be a little tricky. For sure going to take a look at 19 in a minute. Are there any other non-X'd ones out on this page that you're kind of looking at going, let's chat? Because I'll jump into any of them. Kind of start with 19, and if we want to come back, we can. So find the error in the problem. We've done a lot of this cycle, and correct it. All right, let's see here. Distribute 3x minus 15. Okay, that's good. Ooh, what about going to the next step, though?
They added 2 and not minus the 2.
There's our problem. So, plus 2x instead of minus 2x. All right, so let's fix this. Let's go with this one. So here, and you don't have to redo the whole thing. Just we're gonna start at the last step they were good with, and we're gonna fix it. And again, whenever you see these find the error problems, there will be an error. It may be real subtle. It may be something we're kind of not ready for necessarily, but it's going to be there. So we just got to give it a little bit of time. But also when it says find the error, circling it works, describing what it did works. Again, I'm not going to be real picky about that. I just want to make sure that we've got a good solid idea here on what that error probably would be. All right, let me see what else we got coming still to make sure I'm being a good teacher, giving ooh. All right, let's see here. 22 helps if I'm on the screen. Okay, this is one of those compound ones that gets a little funny. So again, the goal is to get the x alone in the middle. And this is a little similar to one we saw earlier. Both of these x terms are in the middle. They're not one in each place. They're together, no opposites. We're going to put those together. Now the goal, just like it does with an equation, becomes get x alone. But whatever I do in the middle, I've got to do to all three parts of my inequality. And as long as I keep doing that, I really could have done better if I would have made those boxes a little bit bigger. So I get this set, and just like we said when we did this originally, if I recognize that it's a compound, that it's an and statement, I know that it's just going to be coloring in the middle. Because what we could do here is you could be like open circle, or if you, when you dealt with it in algebra, if you did the parenthesis thing here instead, that's fine as well. Kind of looks like a barbell. Or if you're more comfortable doing them separately, you could be like, okay, x is less than 4. So, you know, I'd have my little arrow going here to the left because x is less than. And then I'd cover this, but I'd have to be careful. It doesn't mean the arrow's going left at 2. The arrow is eating the x. X is greater than 2 means we're going to go to the right. And that's why we color in the middle, because the two arrows are just going to clash with each other anyway and get to that solution set. So just color it in the middle. We should be pretty good there as well. And I think, ooh, I got one more piece back here. All right. And again, this is just to kind of give you an overview on some things. Again, totally your call here. When you're looking at these, and I want to do a couple, because I know there's a couple questions on the quiz that are going to go down this road. So back here, again, we're trying to find the missing side. Now, sometimes that's going to be real straightforward. Other times it's not. So for example, when's it not being straightforward? If we're looking for the missing sides, for instance, here, I have two missing sides that I'm working with. And I need to know what both of them are. So my first job, I'm going to kind of separate these by color. So over here, there's my C. Here's my A and B. So for this piece, I'm gonna go Emily style here because I want to shorten this up because I don't have a ton of room. So we're gonna do C squared minus A squared. We're gonna find that first piece. Minus, 7 squared minus 5.2 squared. So we got 21.96. Then we got to do the square root. Oops. So B is like 4.7. Okay, so there's my first piece. But I'm still being asked, I still got a piece down here too. So there's my C. Now in my pink triangle, I'm trying to find my other leg, my A value. So you look and you're like, okay, so let's do that again, because again, I'm looking for a leg. So 7 squared minus 4.7 squared is going to give me my other leg. I probably could even put this on the calculator at once, but... So the square root... Okay, and I get both my sides. Even if you were asked a question, let's say, like, hey, find the missing sides and then find the perimeter. That is now with A and that other value, you can find everything around the edge. Hey, find the area. Okay, I can do base times height on each of these triangles, divided by 2. Put them together. So when we're looking for these, look for the triangle where you already have at least 2 of the 3 pieces, and then kind of work your way backwards. And again, the directions are different from the original there. I just want you finding the missing sides. So find the ones that are the craziest and deal with those. The ones like 1 through 4, you've kind of done those already. But the rest of them, you've got a little bit to challenge you with, and you don't need to do every single one. Like pick odds, pick evens, or just pick a side of the worksheet as you're going. You're going to get a good mix that way. I do have keys up front. I do have keys online as well if you want to check something over as you're working along to make sure you're good. We will have, like I said, some time to finish up some things tomorrow if we've got questions or if you just need some time to work, but I'm still working on a way to kind of review this without giving too much away.